Hello and welcome everybody to the third part of our tutorial series, Cybersecurity and Low Voltage Power Distribution. My name is Andreas Hill, and within this tutorial, I want to show you cybersecurity based on a system architecture. So let's start. Within a physical structure of a power distribution, as many of you know it, of course, within, for example, a main power distribution panel, you have intelligent products that are connected. So normally you have all these products that you can see here. You have an air circuit breaker, you have some molded case circuit breakers, you have most, or in some cases also, some fuse-based protection devices. You have some classical meterings or measurement devices. And in some cases, you also have some display functionality over there within, for example, the DSP-800. In some of the plants, there are also some data collectors, just like the Power Center 3000. And mostly these products that are communicative capable devices are interlinked to each other. So for that, let's have a look at the network topology. So within our main distribution, we have all these products connected by or to a single switch. In this case, we have a scale-in switch that is managed, and each and every product is communicating throughout a classical Ethernet communication with each other, or especially to a product within this plant, the Power Center 3000, the data collector. So the data collector has two network interfaces, one internal and one external. So the internal, of course, is also connected to the switch, whereas the external is connected to the local intranet of the company. Within this local intranet, there are more functionalities realized on a security way within a switch, for example, or within a router. So from that perspective on, we are able to communicate the data either to the cloud in order to have a broader view or to have availability of the data worldwide, or we have the possibility to just use a PC with a monitoring software. We can have some energy monitoring or some predictive maintenance on that. Besides of that, there is the possibility, of course, for maintenance or service reasons to integrate a service PC right to the switch here, where we have our dedicated service software or maintenance software, the central power config. So let's have a more detailed look on this network topology. So let's have first a look on the left part of the slide, where it deals with the internal communication of this power distribution. So when we just keep all these products together within one single network, we see that this communication within the panel is done via a Ethernet connection and is communicating via Modbus TCP. Modbus is a field-based protocol that is designed or that is used in an unsecure way because there is no encryption inside the communication. So that means each and every participant of this network could listen and could see all the data in clearance. In fact, there is the Power Center 3000 who is collecting all these data that is provided by the communicative capable devices. Of course, in an unsecured way. That means this part of the network needs to be protected. On the other side of the power center, there is an external interface on that side here. This external interface is connected to the local intranet. And from this part, it is possible to encrypt the data that comes out of the Power Center 3000. So all the data that is captured right from the devices is stored within the Power Center and then is provided to the intranet on a secured way or on an encrypted way. From there on, no one could easily access the data or just manipulate the data, which is a big benefit, of course. That means the Power Center 3000 in that case is in the function of a security gateway. And that gives us some big benefits, of course. When we have a look at the power center as some kind of security gateways, we have different opportunities or possibilities that this product has. So at first, of course, it is our single point of entry to the data of the plant, of the power distribution system. The second thing is that if we do some security adjustments on these products, we can secure the whole plant by, for example, adjusting some firewalls or implementing some firewalls. If we just cut off the direction between the internal and the external network. And so we have an advanced security in that way. There's also the possibility, as I said, to encrypt the data. So if someone wants to have this data outside the company in order to compare the data of different plants or different facilities, then you can have a cloud connection that is done with a secure communication. And of course, there is a benefit that the power center collects all the data and stores it inside a database. So that means if you access the data from outside, you only have a look on a copy of the data of the original products, and you are not able to access each and every product within this plant. So that means if someone wants to attack your power distribution, he is not able to attack the single products. He is just able to attack the power center itself. And of course, it's not only the power center within this system approach or within the system architecture that needs to be secured. Also, the single devices have to be hardened. And therefore, and also for this adjustment, for this documentation, there is one commissioning software that we can use. The commissioning software Centron Power Config. With this free of charge software, you are able to parameterize, to diagnose, to document, and of course to restore or backup your whole plant. So that means you can do the parameterization, the hardening of each and every communicative capable device within your plant. You can adjust all the security possibilities that the product brings along. You can have some diagnostics on the product itself, either if you want to do a firmware update or upgrade, if you want to load some security patches to the product. You also have the possibility just to extract the whole project setup as a single file in order to load it or reverse load it to your plant in case there is any issue or there is any failure within the plant. And of course, you're able to extract a whole documentation. So that means once you did all the adjustments, the hardening, and the product documentation, you can just create a PDF file or a single project file out of it and just place it at your documentation part. So from this perspective, the single products in combination with the software is a big benefit and a big system approach in order to secure a whole power distribution. That's all for now. We're done with our third tutorial on cybersecurity for low voltage power distribution. If you want to find out more on cybersecurity, more on how to secure low voltage power distribution, even if you want to communicate not only wired but also wireless within your power distribution, find out more information on our homepage. You can find it here below the siemens.com/low-voltage/cybersecurity. Find out for white papers, webinars, and all other cool stuff. Thanks for watching. See you.